DC Pit analyzes foundation pit walls according to the Eurocode and many other international codes. It allows the use of bore pile walls, diaphragm walls, sheet pilings, girder plank walls, or the mixed-in-place system. With the groundwater earth pressure function, users can define the groundwater depth below the surface, the design standards, and many other parameters. The program contains analysis and design standards, including German and Swiss norms, as well as British Standard and Eurocode. It is possible to enter up to 3 other standards. For the analysis according to Eurocode 7, there are several national annexes already predefined. A definition for any other country is also possible. In the settings for Eurocode 7, there are sections for wall length, anchor length, and piping, with the corresponding design approaches and safety factors. For dimensioning of the pit wall, Eurocode 2 and 3 can be selected depending on the type of wall. Here again, several national annexes are predefined with an option of additional national annexes. For Eurocode 2, there are general parameters for the design, shear design, and minimum-maximum reinforcement. For Eurocode 3, there is one dialog page for any type of verification, general parameters for the design, verification of stability, and reduction coefficient beta for sheet pile walls. The wall unit may consist of one line or of several sections that may have different inclination and be of different types. The following wall types are available: bore pile wall, diaphragm wall, sheet piling, girder plank wall, and mixed in place with predefined profile parameters ready to use and the possibility for custom definition for every wall type. In this example, we will use sheet piling with profile Larsen 604. Layers run horizontally behind the wall and may be defined by the depths of their top edges. Since, outgoing from the ground surface, the first layer is defined with the input of the construction pit wall. Every layer can be defined with free entering of the parameters or using the parameter suggestion, where a layer name is selected and all the layer parameters are predefined. We use skin friction and end bearing for the vertical equilibrium. The inclination of the passive earth pressure can be iterated. Up to 2 slopes or terraces may be entered, which may also be vertical. The following loads can be entered: concentrated, forces and moments, and distributed, area loads. The loads can be in different load cases and can be dead, live, or railway loads, limited or extended. To enter an anchor, the following has to be defined: depth of the anchor head below the wall head, anchor inclination to the horizon, minimal length of the anchor, anchor elastic, alternatively the anchor may be used as an elastic spring instead of a fixed bearing, length of the bond section, length of the projection from axis, and horizontal anchor spacing. The next step is the definition of excavation phases. You may define different pre-construction and dismantling stages and assign anchors and other parameters to them. First, you enter an excavation stage by its depth and name. Next, you can enter other parameters including water level and bearing surface, anchor dimensioning data, modulus of stiffness for the elastic support, and earth pressure redistribution. Different bearing stages are possible for the wall toe, from free to fixity according to Bloom. You may define a slope in the construction pit base for every excavation stage. The equilibrium of vertical forces may be verified according to the recommendations R9 and R84 of EAB. After the calculation is performed, the program displays the analysis results in an editor as a text, including earth pressures, the final wall loading, as well as the resulting section forces, M, Q, and N, and deformations, supporting forces, and eventually bedding forces and anchor analysis. The first excavation stage was calculated with fixing according to Bloom, because no anchors are available. We see that the required wall length is iterated for an end moment of 0. The second excavation stage contains a free support of the wall on the passive earth pressure. Here the required wall length is calculated for the horizontal equilibrium. The results contain checks of the vertical component of the mobilized earth resistance according to EAB, EB9, and checks of the transfer of vertical forces into the underground according to EAB and EB84. If the check is not fulfilled, the program shows that the wall length has to be increased for additional skin friction. After the additional wall length is added, the check is OK. With the dimensioning option, you may calculate the profiles or the reinforcements for all wall types, as well as additionally the infilling of girder plank walls, bore pile walls, and mixed-in-place walls, where the infilling can be concrete or timber, the anchors, and the boom. With the suggestion option, the program uses calculations to optimize the profile sections selected. Every element of the pit wall can be changed easily using the left mouse button. Now we change the type of the wall to bore pile wall. In the case of reinforced concrete components, the required reinforcement is defined, and it may optionally be output by the definition of reinforcement meshes. Changing the parameters affects also the documentation. The program may create for each construction stage in each load case a graphic of the ground situation with wall geometry, ground surface course, layers, water levels, and loads, as well as an overview of the loadings, section forces, and deformations. Please find further information about DC Pit, other DC products, and a free demo version under www.dc-software.de.